Chapter 5.6, Differential Equations, Growth and Decay, Day 1. We're going to start out with looking at a differential equation. Differential equation is just an equation where we're given the derivative. Most of the time we've been given something like dy dx equals 2x or dy dx equals 3x minus 4. Today we're going to be given something where there's two variables in it. In this case, y prime equals 2x over y. And we're going to be asked to solve it. So as we solve this, let's remember that y prime is really dy dx equals 2x over y. And what we're going to want to do in this case is we want to get all the y's together on one side and all the x's together on the other side. This is a method called separation of variables. Right? So I'm going to multiply both sides by y, multiply both sides by dx. So we'll get y dy equals 2x dx. And how do I solve derivatives? Well, work backwards, be antiderivative. All right, antiderivative of y is 1/2 y squared. You could say plus c. The antiderivative of 2x is x squared, or 2x squared over 2, and you could say plus c. Well, these are different constants. I'm going to do c1 and c2 on these. All right, let's solve for y. I'm going to move c1 over. So I got 1/2 y squared. We all know that 2 over 2 is 1. So this would be x squared plus c2 minus c2, or minus c1, sorry. Here we have a bunch of constants we don't know. Why have a whole bunch of constants we don't know when we can simplify them into just one constant we don't know? So we got 1/2 y squared equals x squared plus a constant we don't know. Let's get rid of the 1/2, so we'll double everything. 2y squared, or y squared equals 2x squared plus 2 times a constant we don't know, which is a constant we don't know. And then we'll square root. So y equals plus or minus the square root of 2x squared plus a constant. All right? That's differential equations. That's solving differential equations. And we can take it a little bit further with the exponential growth model. Exponential growth model says the rate of change of a substance is proportional to the substance that's already there. The rate of change of y is proportional to y. Or we could say dy dt equals ky. Now if we were to solve this, it would give us this general idea. And this would be the general solution. And you should recognize this from your pre-calc days as the exponential growth and decay equation. Y equals ce to the kt. Some books or some people say y equals pe to the rt. Either way is fine. C represents the initial amount and k is a proportionality constant, meaning your rate of decay or rate of growth. All right, so here's a problem. The rate of change of y is proportional to y. So that means it's going to be y prime equals ky, or if we solve that, y equals ce to the kt. When t equals 0, y equals 2. And when t equals 2, y equals 4. What is the value of y when t equals 3? Well, we're using 0 and 2, and then 2 and 4 to find your values for c and k. Since t equals 0 is what you start at, that means that 2 is c. So y equals 2e to the kt. And then t equals 2, we can plug that in. Y equals 2e to the 2 times k, y equals 4. We'll substitute that in for y, and then we'll solve for k. So 2 equals e to the k2, natural log of both sides. So k equals 1/2 the natural log of 2. So our equation, y equals 2e to the 1/2 natural log of 2 times t. What is the value of y when t is 3? Plug in 3 for t. So 2 times e to the 0.5 natural log of 2 times 3. Y is 5.656. So when you solve these, you're going to get a couple initial conditions to help you find your K and your C, and then you may be asked for more information from there. All right, so here's an example. Radioactive decay is measured in terms of half-life, the number of years required for half the atoms to decay. The rate of decay is proportional to the present amount. That lets us know it's growth and decay. Rate of decay is proportional to the present amount, so we know it's a PERT problem, or CE to the KT. All right, our question is, suppose that 10 grams of plutonium was released in the Chernobyl accident. How long will it take to decay to 1 gram? All right, so plutonium has a half-life of 24,100 years. So the half-life equals, I forgot it already, 24,100. All right, since it follows the equation y equals CE to the KT, we know that 10 is our starting amount. So that's 10 e to the KT. And half-life is 24,100 years, so 5 grams are left after 24,100 years. That'll allow us to find our K. Divide by 10, take the natural log. Natural log of 1/2 equals 24,100 K. You're going to find for half-life, this number is always involved, natural log of 1/2. So K is the natural log of 1/2 divided by 24,100. And if you want, you can estimate that out and stick it into your equation. But for 1 gram to be left, we got 1 equals 10 e to the k, which is natural log of 1/2 over 24,100 times t, divide by 10. Undo the e with the natural log, so the natural log of 1/10 equals the natural log of 1/2 over 24,100 t. And so we'll just take this and divide it by that. So the natural log of 1/10 divided by, I'm going to group that other side, natural log of 1/2 divided by 24,100. And we see it'll take 80,000 years. 80,000 years for 10 grams to become 1 gram because the rate of decay is so high, or so slow. Half-life is so high. Suppose there is an experimental population of fruit flies. Increases according to exponential growth. Y equals CE to the KT. There were 100 flies after the second day and 300 flies after the fourth day. How many flies were in the original population? All right, so after the second day there were 100 flies. So 100 equals CE to the 2K. 300 flies after the fourth day. 300 equals CE to the 4K. All right, so let's solve for K in one of these. It doesn't matter. What we'll do is I'm going to take this one, divide by C, so 100 over C equals E to the 2K. Natural log of 100 over C equals 2k. So k equals the natural log of 100 over c over 2. All right, substitute that into the other equation. 300 equals CE. And this is where it gets a little tricky. 4k, really this is 2, so 4 over 2 natural log of 100 over c. Now 4 over 2 is 2. So CE to the 2 natural log of 100 over c. Now remember what that 2 does in front of the natural log? It goes and becomes an exponent. So 300 equals CE to the natural log of 100 over c squared. Now, what does e natural log do? They cancel. So we got 300 equals c times 100 over c squared. And that you can solve for c. We got 300 equals 10,000 c over c squared. All right, cancel one of these c's. 300 equals 10,000 over c. Multiply by c. Divide by 300. We got 100 over 3, which is about 33 1/3. So the initial population there was about 33 fruit flies. So in conclusion, for exponential growth follows the model the rate of growth is proportional to the amount present. Right? Y prime equals ky. If you solve this, meaning you separate your variables, get your y's on one side, your x's on the other, you will find that it simplifies down to the exponential growth and decay equation, y equals CE to the KT, or some people have learned y equals PE to the RT. Later we will see exactly how that simplifies to that.